In this section, we'll take a look at the Configuring and Monitoring Spanning Tree objective of the JNCIS Service Provider exam. We'll examine how to configure STP, i.e. Multiple Spanning Tree Protocol, and see how spanning tree converges to a loop-free topology. For more detailed coverage of this objective and more, please check out the Juniper Service Provider Switching course. In this video, we're going to take a look at configuring and monitoring spanning tree. Specifically, we're going to take a look at multiple spanning tree, or MSTP. And we have this topology here of 3 switches interconnected. These are actually 3 virtual switches implemented on the same MX device, but for our purposes, we will treat them as completely independent. And they are interconnected via this ring topology. So if we were to run standard layer 2 switching over this topology, we would have a loop, and we would quickly overwhelm our links with looped traffic. So we have to implement spanning tree to break this loop. So we'll first configure VS2 for multiple spanning tree. VS1 and VS3 have been configured ahead of time. So with spanning tree configured on VS2, we'll see how spanning tree converges to provide a loop-free topology on this network. And then the main benefit of multiple spanning tree is that you can have separate forwarding topologies mapped to different VLANs to maximize the use of your installed capacity. And we do this by mapping different instances to different topologies. So we'll show how we can alter which links are used for forwarding for different instances by changing what should be the root bridge for each of our 2 instances that we create. We'll make virtual switch 1 the root bridge for instance 1, and we'll make virtual switch 3 the root bridge for instance 2. And we'll see how that affects our forwarding topology. So let's now get on and configure this spanning tree protocol on our switching network. So we have these 3 virtual switches configured on this router. Virtual switch 2 has no spanning tree configuration, and we're going to need to add spanning tree configuration to this virtual switch. Virtual switch 1 and virtual switch 3 all have their spanning tree configuration in place already. But let's configure virtual switch 2 for spanning tree now. So we're going to drop into the virtual switch routing instance configuration. And we're going to be configuring multiple spanning tree protocol. First thing we need to do is set the revision level. Remember that within multiple spanning tree, a region has to have the same revision number and the same VLAN to instance mapping for a multiple spanning tree region to be able to form. So we're setting the same revision level as we have configured on our other 2 virtual switches. We need to specify the interfaces. If you can just see there, these are the interfaces that are underneath this virtual switch. And we also need to configure our instance to VLAN mapping. So there we have it. We have our spanning tree configuration in place. We've now committed our configuration. Let's take a look at our spanning tree interface state. So we can see that virtual switch 1 for both instances, he's the root bridge. And on virtual switch 2, we see our root port for each of the instances, and VS2 is also the designated bridge for both VLANs facing into the link into VS3. We have a look at VS3. VS3 has his root port facing into virtual switch 1, but the port facing to virtual switch 2 is blocking. Let's just take a look at our network diagram again. So virtual switch 1 is the root bridge, and he has these ports both in designated port mode, and they're both forwarding. Virtual switch 2, this is his root port, and this is the designated port. And on virtual switch 3, this is the root port, and this port is in blocking. And this topology is the same for both of those VLANs, for both VLAN 111 that's mapped to instance 1 and VLAN 112 that's mapped to instance 2. So obviously there's not much point in running multiple spanning tree if you're going to have the same topology for all your instances. So let's configure instance 1 and instance 2 slightly differently by electing a different root bridge for each instance, and let's see how that affects the port modes that are assigned to the various different ports in the various different topologies. So let's create a superior bridge priority for instance 1 on VS1, and let's do the same for instance 2 on virtual switch 3. And let's commit this configuration. And let's now see how this has affected our forwarding topologies for those different instances. See, now we're looking at virtual switch 1. On virtual switch 1, we have our instance 1 and instance 2. You see that for instance 1, he is the root bridge, but for instance 2, he's not. And he has a root port facing out across one of his interfaces. We have a look at virtual switch 2. See that again we've got different port roles depending on the instance. And again, let's finish off by having a look at virtual switch 3. You can see he is the root bridge for instance 2, so he's going to be forwarding on both of these ports. But for instance 1, he's going to be blocking on this port and forwarding on this port. So you can see that by configuring a different bridge priority for different instances for spanning tree, we can create different forwarding topologies with multiple spanning tree, allowing us to send traffic across different links for different VLANs that have been mapped to different instances. And overall, in general, you can see how spanning tree can be used to provide loop-free topologies in layer 2 networks.